Hi everyone, welcome back to Intermediate Algebra, MATH051. I'm your professor, Mark Williams, and today we're going to look at some more sections out of Chapter 7 dealing with rational expressions. And just want to remind you, when you go out to MyLabs Plus, under the extra media, there are videos that show lectures of another professor that comes along with the book that shows a lot of these. So I want to use this time to sort of supplement what they say by working some different problems and maybe tackling some of the things that you find more difficult to do. So just looking at 3 problems to start off today. Looking at this one, 64 and -3/2 to the 1/3. Well, you can look at this in a number of different ways, but first of all, let's keep in mind that a to the m to the nth power is a to the m times n, right? So, wanting to solve this, then that would give you 64 to the -3/2 times 1/3, right? So the 3's cancel, and this gives you 64 to the -1/2. Well, we know from the law of negative exponents that this then becomes 1 over 64 to the 1/2 power. Now we know that the 1/2 power is the same thing as the square root, so this is 1 over the square root of 64, and the square root of 64 is 8, so the answer to that problem is 1 over 8. Okay? So, looking again at number 2. You have the square root of 5 times the square root of 20. You know, we can put all of this under the same square root. Okay? And that would give you the square root of 100. Okay? Well, we want to be able to eliminate the square root altogether. Well, we know that 100 is the same thing as 25 times 4. So we can rewrite this as the square root of 25 times the square root of 4. Okay? And what you'll get is 5 times 2, which equals to 10. So the answer to that is 10. But what if we wanted to solve this a slightly different way, right? Maybe it'd be more fun to solve it in a different way. So let me erase this, and let's break down the 20. Let's do that instead. So we could also write this as the square root of 5 times, and then this is the same thing as the square root of 4 times 5, which we know becomes the square root of 5 times 2, pulling the 4 out, square root of 5. The square root of 5 times the square root of 5 is 5. This becomes the square root of 5 squared times 2, which is 5 times 2, which is equal to 10. 2 different ways to solve the same problem. Pretty nifty, huh? Well, looking at the third problem. Looking at the third problem, these are both square roots, so we can combine the roots. And we're going to use our handy-dandy rules that we learned in section 7.2 for exponents. So writing this all under one exponent, we have 4 times 4, b times b cubed, all of that over 5 times 5. Okay? And so looking at that, now we're going to rewrite this as the square root of 16. Now b, remember this is b to the first there, b to the first times b cubed, well you add those because this is the product rule, not the power rule. You add those, and that gives you b to the 4th over 25. Now, we want to break this down a little bit more. We can break this down to the square root of 16 times the square root of b to the 4th, all that over the square root of 25. Okay? Which is going to give you an answer of 4b squared over 5. 4b squared over 5. Okay? So those are 3 examples of dealing with different radicals. Let me work just a few more for this video. So this is simplifying radicals. But let's consider a little bit different case. What if we said what we wanted to multiply radicals? Let's look at an example where we're going to multiply a radical and then maybe the addition of a radical. But let's look at multiplying. Let's do 5 plus radical 7 times 2 minus radical 7. Okay? Well, back in the previous section, we learned how to FOIL, F-O-I-L, first, outer, inner, last. So we're going to do the same thing here. These are two binomials. They just contain rational expressions this time. So the first is 5 times 2, right? The outer is positive, no, a negative 5 square root of 7. The inner is a positive 2 square root of 7. And the last is a negative square root of 7 times the square root of 7. Okay, so obviously 5 times 2, okay, is 10. Now, another example, which I'm sure you've looked at and you've worked in your problems already, is when you're adding and subtracting radicals, you're adding and subtracting radicals with the same terms, like terms. So you can actually subtract these or add these, combine these, because they have a common term of radical 7. So negative 5 plus 2, hopefully you're good with your negative signs, gives you a negative 3 square root of 7. Okay? And then we know that the square root of 7 times the square root of 7 is actually just 7. Right? And you're thinking, well, how do you know that? Just on a side note, very interesting, watch this. We know that the square root of 7 can be rewritten as 7 to the 1/2 power, correct? So we're going to write this, taking a look at this here, this is 7 to the 1/2 power, right? Times 7 to the 1/2 power. And we know that that can be rewritten because of our product rule is 7 to the 1/2 plus 1/2, which is equal to 7 to the 1st power. You could consider that to be proof that 7 squared, radical 7 times radical 7 is just 7. Okay? That's free of charge, by the way. That's an extra thing for you, a little free of charge. So looking at this, we can now combine these two terms, 10 minus 7, so the answer to this is 3 minus 3 radical 7. Okay? Now, one last thing in these first two sections is dealing with conjugates. To be in standard form, you can't have a radical in the denominator. Okay, so for instance, what I'm referring to in this is have something like 2 over radical 5. Okay? This would not be, if you're taking the test and you work a problem out and you get this to be the answer, this won't be one of the possibilities. Or if it is, it's a trick because you can't have a radical in the denominator and have the final answer. This is not the most simplified form. And so what you do is multiply the top and the bottom by, in this case, radical 5. And because of what I just showed you, a radical times the radical of itself is just the number itself. So square root of 5 times square root of 5 is just 5. Okay, so writing this in most simple form, you get 2 square root of 5 over 5. Because square root of 5 times the square root of 5 is 5. Okay, now, looking at this in another way, that's a simple formula. How about if we have 3 over 1 plus the square root of 3? Not so easy. However, you can't have a radical in the denominator right? And actually have your final answer. So what do? We multiply by the conjugate. Now how do you multiply by the conjugate? Just like we multiplied by in the last problem, but this one, we're going to multiply top and bottom by 1 minus the square root of 3. 1 minus the square root of 3, top and bottom. Now, why would we do that? Well, the reason we do that is because multiplying this times this in a problem, we just worked a problem similar to this, multiplying this times this, okay? Multiplying these two problems, when we put them together, right, this will eliminate the radicals on the bottom. Let's watch. So on the top we have 3, right, times 1 minus the square root of 3, and on the bottom we're going to FOIL again. So 1 times 1 is the first term, that's 1. The outer term is a negative square root of 3. The inner term is a positive square root of 3. And the last term is a negative square root of 3 times the square root of 3. Alright? And so looking at this, then obviously the top you can multiply through 3 minus 3 radical 3. And then on the bottom, let's take a look here. We've got a 1. Oh, but look at this. Square root of 3, negative, plus these actually cancel themselves out. Right? And then the square root of 3 and the square root of 3, those two right there, the square root of 3 and the square root of 3, we know that square root times square root is just the number itself. So the bottom becomes 1 minus 3. So the answer to this problem is 3 minus 3 over square root of 3 over negative 2. Okay? So very simply, the way that you eliminate a radical on the bottom is to multiply it by its conjugate. Okay. So, in the next video, we're going to be looking at the next two sections of Chapter 7, Sections 7.6 and 7.7. But in the meantime, this should help you out with Sections 7.3 and 7.4. Good luck and keep up the hard work.